All right, last class we left off. We had just learned a little bit about solution mapping. And by a little bit, we looked at like 10 slides in a row about solution maps and problem solving. And we're going to be doing a bunch of that today. We learned about metric prefixes last time, some of the important ones being kilo, centi, milli. There's other ones that are important that we would use more in our regular daily life, perhaps like mega and tera and giga. That being said, we'll start off with this exercise. Hopefully some of you have been looking at it already. We want to convert 1,342 meters to kilometers. So the thing that we're given is meters. We want to convert that to kilometers. The only difference between the two of these is one of them has the kilo prefix. A lot of these metric prefix problems can be solved in one step. Some of them might be a little bit easier if we choose to do them in two steps instead. If we've got prefixes on both of our numbers, it's sometimes simpler to do them in two steps. This one we can do in one step because we only have one prefix. So we want to go from meters to kilometers. We can do that in one step. We need to know, what does kilo mean? Does anyone know what kilo means? It's 1,000. Kilo equals 10 to the 3, which is the same as 1,000. So 1 km equals, if we swap in the 1,000 for the k, it equals 1,000 meters. That would be our conversion factor. The other way you might remember this, a meter is about 3 feet, about a yard. A kilometer is closer in length to a mile. They're not the same, but it's closer in length to a mile. It's a long distance. A meter is not that long of a distance, so a kilometer is a lot bigger, and it's different by 1,000. So starting with our 1,342 meters, we want to convert this to kilometers. Which one's bigger, kilometers or meters? Kilometers are bigger. They're much bigger. They're 1,000 times bigger. So we would expect a bigger or smaller number? Smaller number of kilometers, since they're much bigger. Okay, the conversion factor, again doing this big long line through to separate our top and our bottom. We want to get rid of the meters, so we're going to put the 1,000 meters part on the bottom. That way we've got 1 meter unit on the top, we've got a meter unit on the bottom, and the 1 kilometer part of our conversion factor goes on top. This is the sort of shortcut, the magic way of doing it. And then we check and make sure that we've got a meter on top, we've got a meter on bottom, so those will cancel. Just give those a line through. And then the kilometers is the only unit that's left. So to convert from meters to kilometers, we divide by 1,000. Dividing by 1,000 is the same as moving our decimal place to the left 3 times. So this is going to be 1.342 kilometers. All of our metric prefix conversions are exact, so we don't have to worry about significant figures. We just rewrite the numbers, shift it over. Once you get more familiar with kilo and centi and milli, when those show up, you can just scoot the decimal place over 2 or 3 times, depending on which way we're going, or however many times. You don't even need to show the conversion. I usually, when I do it myself, I don't bother writing it out. But for class, we're doing it to show you how it's done. Questions about solving this unit conversion problem?
So because we know the exact conversion, significant figure does not matter, correct?
Because this particular conversion is exact. 1 kilometer is exactly 1,000 meters, and so it's going to retain the 4 significant figures that we had. So we just scoot the decimal. We don't change any of the numbers. We don't have to round, nothing like that. All right, so that's been a brief look at one-step unit conversion problems. However, we're often going to have multi-step unit conversion problems or just multi-step problems. It's the same procedure, but surprise, surprise, there's more steps. So we are going to, just like before, determine a solution map, and then we'll follow that solution map, whatever we've put together, to figure out the answer to the problem. So as an example, we want to convert 194 centimeters to feet. So from centimeters going to feet. What is a unit that we can convert one of those numbers to, or one of those units to? Inches. Which one can we convert to inches? We can convert centimeters to inches. Can we convert inches to feet? We sure can. Okay, so we've got ourselves a two-step problem. What is our conversion factor between inches and feet? How many inches are in a foot? 12 inches equals 1 foot. How many centimeters or how many inches are in a centimeter? How many centimeters are in an inch? What's our conversion factor there? It's 2.54 centimeters equals 1 inch. So starting with our 194 centimeters, our solution map tells us that our first step is to convert to inches. So we're going to use this 2.54 centimeters equals 1 inch as our conversion factor to get to inches. That means we need the centimeters to cancel out. We need the inches to stick around, so inches will be on top. So the 1 inch part goes on top, and the 2.54 centimeters part is going to go on the bottom. We do this so that our centimeters cancel out. So we followed our first step. We used one conversion factor, took care of this one arrow, and we've got our second step. Our second step is converting from inches to feet. So we're going to use this 12 inches equals 1 foot. Again, we want inches to cancel, so the inches from our conversion factor need to be on the bottom. The 1 foot needs to be on the top. That's the unit that sticks around. So our inches cancel, and the unit that's left is feet. Any questions about setting that up? Yes?
If we don't set it up like that on the exam, will we deduct the points? If we just make it like more simpler?
So on the exams, they're multiple choice. So you either pick the right answer or you pick the wrong answer. That's mostly because if I teach a double section and I've got like 64 students, I don't want to grade 64 exams of all free response. The Scantron makes it a lot easier for me. Okay, so then what we're putting into our calculator, everything that's on the top gets multiplied. Anytime you multiply by 1, it's the same thing, so I just ignore those when I put them in. So 194, and then we're going to divide by 2.54, and we're also going to divide by 12. These are both exact conversion factors, so we're going to have, how many significant figures does 194 have? How many significant figures does this number have? 3 significant figures. So our answer should also have 3 significant figures. These are both exact, so they're infinite sig figs. So calculator says 6.364829396.
Excuse me, she has a question.
Question?
Yeah, can you re-explain?
Where'd you get lost?
The 2.5, no, not everything, I lost something.
Okay, so both of these conversion factors, hopefully 12 inches and 1 foot, that's one that a lot of people know. It should be on your yellow sheet anyway. The 2.54 centimeters equals 1 inch. That should also be on the yellow sheet. That's one that I don't expect you to know yet, but I like having that one memorized. That's an exact conversion factor as well. It should say on your yellow sheet. For setting them up, we're turning them into fractions. So the way that we do that for maths is we divide both sides by one of them. So we could divide both sides. I'll rewrite it up here. 2.54 centimeters equals 1 inch. Last time we looked at making the two possible forms of this conversion factor, and they're just flipped from each other. So if we divide both sides of that by 2.54 centimeters, we have to do it to both sides so that it's even, Stevens, fair and square. One of our conversion factors that we would come up with is 1 inch over 2.54 centimeters. The other one would be if we flip the top and bottom, that's free. It doesn't cost us any money, and it hopefully doesn't cost us that much brain power either. So those would be our two conversion factors. And then if we wanted to, we could just try plugging one of them in and look at how do the units work out. If we plug in the 2.54 centimeters over 1 inch, then centimeters would be on the top twice. So we'd have centimeters squared over inches. And that's probably a unit that you've never heard in your entire life, which means it's crazy units. So we would want to use the other one so that our centimeters cancel out, which is what we did here. And that was the first step. And then the second step kind of follows that same pattern. All right, so this big number that our calculator gave us, we count over to the second 6. That's our third significant figure. Look at the 4 to see how we round. We're going to round this down to 6.36 feet. Final answer. Other questions? All right, the instructions on a box of pasta says to boil 2 gallons of water for cooking the pasta. How many milliliters of water is that? So we will want to access our handy dandy yellow sheet. What are we given in this problem? 2 gallons. How do we know that 2 gallons is the given? It's got a number on it. Usually numbers are stuff that we're given. Not always, but a lot of times, especially for unit conversion problems like this. And what are we trying to find? Milliliters. How do we know we're trying to find milliliters? It's right next to our question word. So just identifying where our question words are can often help us find what we're looking for. It can be a little bit overwhelming to solve word problems. This hopefully a little bit helpful for finding out what we need to do. So we're starting with gallons and converting to milliliters. What's something that we can convert gallons to? We can convert it to liters. Perfect. And can we convert liters to milliliters? We sure can. So milliliters and liters, we've got our millimetric prefix or SI prefix. So we can convert between those two. So we've got a 2-step problem. There's other ways that you could come up with doing this. You could make it probably 5 or 6 steps if you wanted to. This is, I think, the fastest way to do it. So we find on our yellow sheet, we look in the volume group. That's in the left column or the left set of tables, the second little group down. 1 gallon equals 4 quarts, or 1 gallon equals 3.785 liters. It doesn't say exactly after it, so this is not an exact conversion factor, so this is going to have 4 sig figs because of the 3.785. A lot of times if things aren't whole numbers, if they've got a decimal part, they're not an exact conversion. Who knows what milli stands for? It's also on our yellow sheet. The right column closer to the bottom. Milli. 10 to the negative 3. So m, lowercase m, equals 10 to the negative 3. So 1 milliliter. This milli is equal to 10 to the minus 3, so we can swap it in. So 1 milliliter is equal to 10 to the minus 3 liters. This will work if you put it into your calculator. The way that I think of it is I know that milliliters are smaller and there's a factor of 10 to the 3 there. Another way of writing this would be that there's 1,000 milliliters in 1 liter. Both of those work, they're exactly the same when you put them in your calculator. Just one of them has a negative exponent in it. Do we have questions about any of the setup? All right, so that's our solution map. Some of the conversion factors we're going to use. We're going to start with our 2 gallons. And our solution map that we put out says that we're going to convert gallons to liters. That's our first step. And we're going to use this equivalency, this 1 gallon equals 3.785 liters. We're going to use this first. So setting out our big line just so that we've got our top and bottom separate. We want to get rid of gallons and get liters. Which of these numbers, the 1 or the 3, are we putting on top? The 3. So 3.785 liters, 1 gallon on the bottom. Our 2 options for conversion factors, I'll go ahead and write them out. All right, so we've got option A, option B. In this case, we're choosing option B. That's so that our gallons cancel out. So I'll go ahead and strike those through now. So at this point, if we plug this into our calculator, we would get out the liters. We want milliliters though, so we have to do one more step. So using this 1 milliliter equals 10 to the minus 3 liters, we want to get milliliters, so the milliliters comes on top. The 10 to the minus 3 liters will be here on the bottom. And liters cancel. The units that are left over are milliliters. Going to scooch this up a little bit. I accidentally moved my G. Nope. There we go. Okay, so into the calculator we're putting 2 times 3.785 divided by 10 raised to the power of negative 3. So 2 times 3.785 divided by 10. You might have a little caret symbol there, raised to the power of negative 3. On a lot of calculators, you're going to have a different key for negative versus subtract. So that'll usually be, at least on my calculator, the key has this negative in parentheses. So 2 times 3.785 divided by 10 raised to the power of negative 3. And we get 7,570 milliliters. Is that our final answer? It is not our final answer. Why not?
Because the 0 is ambiguous.
It's related to the 0 being ambiguous. It's sig figs. So our box of pasta says 2. How many significant figures does 2 have? 1. So we get to round this for one significant figure. In reality, it doesn't matter. You can kind of just put in however much water you want. We would just do approximately, 7.5 liters, or 7,500 milliliters. But this is a science class, and so we're going to go ahead and do the significant figures. So we need to round for one significant figure. So our one significant figure is going to be that 7. We look at the 5. That tells us we're going to round up. So we'd have 8,000 milliliters. We've got those nasty trailing zeros without a written decimal point. So what do we get to do? Scientific notation. So we're going to turn this into 8 times 10 to the, we move the decimal place over 3 times, 8 times 10 to the 3 milliliters. Final answer. The significant figures part of this question, I would say, is the less important part. Question.
On the 7,570, did you add the 0? Because when I put on my calculator, I only got the 757. Unless I put it wrong.
No, I'm pretty sure that 0 is supposed to be there.
Yeah. Well, because on my calculator it didn't say unless I put it wrong.
We can take a look at that during the break if you want to.
Yeah.
Okay. Any other questions?
I did the second conversion step differently, but I got the same answer.
Okay.
So I did 1,000 milliliters over 1 liter.
Yeah, those are exactly the same. And I think 1,000 liters over, or 1,000 milliliters over 1 liter is probably the easier one because you don't have to do the 10 to the negative 3. It also feels to me like it's like the more sensible way to do it, but they're exactly the same. Yeah. Other questions? All right. Let's say, for instance, that I use 25 grams of coffee beans to make a cup of coffee in the morning. This is true. If I buy a 2-pound bag of coffee, which I often do, how many cups of coffee can I make before I need to buy more beans? So this is a little bit more of a practical question, like what should I set up for my subscription for coffee beans, basically. So I'll give this one to you to try, give you a little bit of time, and then we'll come back together. All right, hopefully that was at least enough time to get started. What are we given? What information have we been given here?
We use up 25 grams of coffee and a bag of coffee is 50 minutes.
Yeah, so we've got this 25 grams of coffee, and we've got a 2-pound bag of coffee. What are we trying to find?
How many cups of coffee?
We're trying to find cups of coffee. So our end goal, I'm going to call it C of coffee. We're trying to find cups of coffee. And are we going to start with pounds or grams? We are going to start with 2.00 pounds. So the tricky part of this question is that this 25 grams of coffee is secretly part of a conversion factor. 25 grams of coffee goes to make 1 cup of coffee. Call it CB, 25 grams of coffee beans equals 1 cup of coffee. That's like the one trick, sort of the question. Figuring out that that's a conversion factor. All right, can somebody help me out with either a starting step or an ending step? What can we change 2 pounds to, or what can we use to get to cups of coffee? What do we need to get to cups of coffee?
Convert grams to pounds.
We can convert between pounds and grams. And can we get from grams to cups of coffee? Grams of coffee beans to cups of coffee.
Yes.
We sure can. That's this secret conversion factor up here. So for pounds to grams, we refer to our yellow sheet. 1 pound equals 453.59 grams. The number that I usually remember is 454, and that's close enough for daily work. Not that I'm doing these conversions every day, but it's sometimes convenient to have it in your brain. So we're going to use this 1 pound equals 453.59 grams because that's what the yellow sheet says. And for the second step, we're going to use this 25 grams equals 1 cup, and we'll just assume the coffee part. So setting up the actual framework with all the numbers for our conversions to put in our calculator, 2 pounds. We're going to put the 1 pound part of our conversion factor down here on the bottom. We're going to put the grams part up top. That's what we're converting to. It's the unit that we want. And this gets our pounds to cancel. And then our second step, we're converting from grams to cups. So the 25 grams goes on the bottom, the 1 cup goes on the top. This gets our grams to cancel. The unit that comes through is cups. So we'll do 2.00 times 453.59 divided by 25. And we get 36.2872 in the calculator. Is that our answer? Not quite, but we're very close. What do we need to do? You're thinking it. Significant figures. So 2.00 has how many significant figures? It's 3. So we've got 3 significant figures. How many does our first conversion factor have? 453.59. 5. And how about our second conversion factor? 2. 2 significant figures. How many significant figures should we expect then in our final answer? 2. We want 2 because 2 is the smallest of those numbers, and when we're doing multiplication division, we care about fewest significant figures. So our 6 is going to be our last significant figure. We look at the 2 to see how we round. This will get us to round down to 36 cups. So if I needed to figure out how many cups of coffee I could make to set up my subscription, I'd probably set up for monthly delivery for a 2-pound bag of coffee. That gives me a couple days of wiggle room. I can have 2 cups of coffee if I want. What a treat. Questions? Okay. We've also got some instances where we'll have unit conversions in both the numerator and the denominator. So for those of you that are a little rusty on your math, the numerator is on top, the denominator is the number on the bottom. So sometimes we'll have 2 units, and we'll have to convert both of them. So for example, a certain hybrid sedan has an estimated city fuel economy, your miles per gallon in the city, of 48.0 miles per gallon. In Europe, they're going to use kilometers and liters rather than miles and gallons. So we might want to calculate the fuel economy, the kilometers per liter that they would advertise in, say, France. So starting with 48.0 miles per gallon, that's miles over gallons, we want to get to kilometers and liters. Which of these 2 units, kilometers or liters, is miles going to convert to? Are we going to convert miles to kilometers or miles to liters? Kilometers. So the kilometers is going to be on the top. It's going to replace our miles. And what about gallons? Is gallons going to go to kilometers or liters? It's going to go to liters. So we're looking for kilometers per liter. Fortunately, these are both one-step conversions. The tricky part of doing these is that one of our units is now on the bottom. We haven't done stuff where it's in the denominator. We've only been doing stuff in the numerator. So that can trip people up a little bit. Cool. Sometimes I set up like an example and then it's the next slide and then I do it all in this tiny little space. So that's why I've been checking. Just forget. Okay, what do we want to convert first, miles or gallons? It doesn't matter, it's just your choice. Cool, let's do miles first. So we know that 1 mile equals 1.609 kilometers. So if we're setting this up, we want the miles to cancel out. The miles is on the top, so the miles from our conversion factor is going to go where? On the top or the bottom? It's going to go on the bottom. So 1 mile in the denominator, and the 1.609 kilometers has to go on top. So we can cross out our miles. And now the units, if we plug this into our calculator, the units that we would get out are kilometers per gallon, which nobody's going to use. We also need to convert our gallons. So 1 gallon equals 3.785 liters. In order for us to cancel out the gallons, which one of these 2 numbers is going to go on top? The 1 or the 3? How do we cancel out gallons? We're going to put gallons on top. So 1 gallon on top, 3.785 liters down below, and gallons cancel. This sort of problem really isn't, I think, that tricky if we can get our units on the correct top or bottom, numerator or denominator. So then into our calculator, we would plug in 48 times 1.609 divided by 3.785. And we get a value of 20.404755561. And then thinking about our significant figures, we've got 3, 4, and 4. So we are going to pick 3 significant figures for our final answer. So this would round down to 20.4 kilometers per liter. Questions? All right, one for you to try. Floris Griffith-Joyner holds the world record in the women's 100-meter dash during her historic sprint. She ran an average velocity of 9.53 meters per second. What was her velocity in kilometers per hour? So I'll give you a couple minutes to give that a try. All right, what are we given?
Dash of the 9.53 meters per second. And kilometers per hour, right?
Yeah, so some potentially useful information. 100-meter dash, 9.53 meters per second, and kilometers per hour. So in this case, this whole first sentence is just flavor text, or what we would call flavor text. It's not actually important to solving the problem, but it just makes it like a little bit more interesting. It provides some context so that we're not just like crunching numbers. It actually gives us like, hey, this is related to something that happened. So we're going to be starting with this 9.53 meters per second, converting to kilometers per hour. This meters/seconds is the same as meters over seconds. It's just how we write it in like text format when we're not doing like math script, math type. And kilometers per hour is going to be km over HR. So going from meters per second to kilometers per hour, we've got a couple of things to convert. What's one thing that we can convert? It's a step that we can start with. Do we want to convert meters first or seconds first? It doesn't matter. It's our choice. Sure, somebody was thinking meters. Thank you for saying meters. So we'll convert meters first. We're going to convert meters to kilometers. So we're going to convert to kilometers per second. So the top then would be what we want. The bottom, though, we have to convert seconds to hours. And we can do that in 2 steps. You could also set it up in a way that you can do it in 1 step. We'll do the 2-step method here. So we'll go to kilometers per minute and then to kilometers per hour. So we've got 3 conversions that we're going to do. In our first step, the thing that's changing is meters is going to kilometers. Kilo equals 10 to the 3, which is the same as 1,000. So 1 kilometer, that K turns into the 1,000. So kilometer is equal to 1,000 meters. In our second step, our kilometers aren't changing, but our seconds and our minutes are changing. How many seconds are in a minute? 60 seconds equals 1 minute. And then how many minutes are in an hour? Also 60. So 60 minutes is a TV show. Also 1 hour. Questions about our solution map? You don't necessarily have to solution map every single problem, but it can be helpful for kind of deconvoluting or figuring out what's the next step that I should do, or what's a step that I could do like at the end. Sometimes we can work our way backwards and that makes a little more sense, or it can be a little easier to set up. Okay, so starting with 9.53 meters over seconds. Put this big long line through to separate our numerator, the stuff that's on top, from our denominator, the stuff that's on the bottom. We want to convert from meters to kilometers, so the kilometers needs to go on top, 1 km, 1,000 meters on the bottom. The meters cancel. And then we're going to be converting seconds. So for seconds, there's 60 seconds in 1 minute. We need seconds on top. And that'll get our seconds to cancel. And then we're converting minutes. So we want minutes to be on top, and the hours will be down on the bottom. 60 minutes over 1 hour. And this gets our minutes to cancel. So the units that are left over are kilometers and hours. If you chose to do it in a different order, that's fine, just as long as you got the numbers correctly on the top or the bottom. That's the most important part. Questions? Okay, so the number that we get out from our calculator, 34.308 kilometers per hour. For our sig figs, this one's sort of straightforward if you've identified the exact conversions. So all of our conversion factors in this case are exact, so we treat them like infinite sig figs. So we're going to have 3 significant figures for our final answer. So the second 3, and this will round down to 34.3 kilometers per hour. So the way that I put it in the calculator, I did 9.53 times 3.6. The way that you'd probably put it in your calculator, 9.53 times 60 times 60 divided by 1,000. Or 9.53 divided by 1,000 times 60 times 60.
What if we got 34.31?
If you got 34.31,
Yeah. Let me redo the whole thing.
I'm not entirely sure. It sounds like maybe your calculator rounded it. Other questions? I did times 3.6 because 60 times 60 is 3,600. 3,600 divided by 1,000 is 3.6. I've done this problem a couple times. Okay, the last type of conversion that we'll talk about in this chapter is units raised to a power. So units with an exponent. If we're converting numbers, quantities, with units raised to a power, units with an exponent, our conversion factor also needs to be raised to that power or exponent. One of the ways that we can see this, let's do an example with centimeters and inches, cubic centimeters, cubic inches. One of the ways that we can see this is if we expand out our exponent. So cm to the 3 is the same as centimeters times centimeters times centimeters. So if we expand it out, we can see that we've got 3 centimeters here, and each of these needs to get canceled out individually. So let's say that we've got 144 cubic centimeters, just so we've got a number to play with. So 144 cm times cm times cm. And we want to go to cubic inches, which is the same as inches times inches times inches. Since we've got 3 of them, we need to apply our conversion factor 3 times. Our conversion factor is 2.54 centimeters equals 1 inch. So we'll apply it the first time, 1 inch over 2.54 centimeters. That's going to cancel out our first centimeters, or our middle one, or our last one, it doesn't really matter. And then we'll do it again. Switching to a different color, just so we can see that we're canceling them out individually. 2.54 centimeters on the bottom again cancels out our second centimeters. We still have 1 more centimeter to cancel out. So we have to apply our conversion factor 1 last time. And that'll cancel out the last set of centimeters. Then, because I ran out of room, you'll find that's a recurring theme. We'll scoot everything over. So that's what we've got. We've got 144 divided by 2.54 divided by 2.54 divided by 2.54. There's 2 ways that I foresee you being able to put this in your calculator. One of those ways, divided by, sign, and then use parentheses. 2.54 times 2.54 times 2.54. Optionally, close parentheses. That'll get you the correct answer. The way that I usually put these sort of things into my calculator is I just divide multiple times. Those will both get you the correct answer. And then there's the secret third way, which is 144 divided by 2.54 raised to the 3rd power. That should also get you the correct answer. Those are all exactly the same from your calculator's perspective. Does anyone have questions on this setup? So the most important part is recognizing our units are raised to a power. It's either going to be 2 or it's going to be 3. Anytime that our units are raised to the power of something, you can either expand them out or just remember to apply your conversion factor the same number of times, either 2 times or 3 times. If you don't remember to do that, you will get the wrong answer, and there's definitely going to be one of these questions on the first exam. And if you only apply it 1 time or if you only apply it 2 times, assuming it's raised to the 3rd power, those will be answers. Those will be options for you to select on the multiple choice. So you might do it wrong and see, hey, that's what I got, and then it's actually wrong. So that's a word of warning. All right, let's put this into the calculator. 1.144 divided by 2.54 3 times. The answer is 8.78741915. We're going to round it for 3 significant figures. So 8.79 cubic inches. Any questions about the setup for that problem, how we did it, etc.? All right, and then here's our example. I'll give you one exercise to do. I'll probably just leave it up when we go on break. The fastest speed in my Kart is 200 cc's. Cc's are cubic centimeters. So cm raised to the 3. Engine displacement, which is a measure of the size of the engine, is often expressed in cc's for motorcycles, usually on like sedans and other things, and like trucks it's in liters. Let's convert 200 cc's to cubic inches. So 200 cc's converting to cubic inches. So this is basically what we were doing on the previous slide. So really, it's just these last 6 or 7 words. That's like all that's important in the problem. The rest of it is just contextualization relating it to Mario Kart, because that's fun. And engine displacement, because that's also a fun fact, in my opinion. Okay, so 200 cubic centimeters. I'm going to write it out as cm to the 3rd power. We want to go to inches to the 3rd power. That 3 means that we need to apply our conversion factor 3 times. Since I already showed us the long way of doing it, I'm going to show us the short way of doing it. So we would find our conversion factor, or have it memorized. 2.54 centimeters equals 1 inch. The fast way of doing it, we take our conversion factor and write it in, and then we cube it. So what this does practically, this 3 distributes, meaning that we put it on everything. So 1 raised to the 3rd power is 1. Inches raised to the 3rd power is cubic inches. 2.54 raised to the 3rd power is 2.54 raised to the 3rd power. I don't know what that is off the top of my head. And then cm raised to the 3rd power is cm to the 3rd power. So this is the way of doing it in one fell swoop. So this cm3 cancels out. The units that are left are cubic inches, and what we're putting into our calculator is 200 over 2.54 to the 3rd power. If it makes you feel better, you can put that bottom number in parentheses, but you don't have to, because exponents will happen before the division. Questions about the setup? We get out 12.204 and all this other stuff. Questions? Assuming all those zeros are significant, it'd be 12.2 inches cubed. If they're not, then we get the very silly 1 times 10 inches cubed for one significant figure. It's one of those two, but the significant figures part isn't important here. Typically on exams, also, I'm either testing you on significant figures or I'm testing you on something else. So usually, like if I'm not testing you explicitly on significant figures, it'll just have the correct number of significant figures. There will be like a couple questions where you actually have to know significant figures. Cool. How many cubic feet are there in 472 cubic yards? I'll leave this one for you to do. I might write it in later and then upload it. And we'll take our break here too.